All right, to start with, we're talking about binomial. What does bi mean? Two. So like bicycle, it's got two wheels, for instance. Yes, there's other words that start with bi. There are exactly two possible outcomes for each trial. Two. That's why the binomial means two. So you can't do this for like rolling a die, but you can do it for a lot of real-world things. Okay, flipping a coin is obviously two things could happen, but there's a lot of other things. Think about it. You either make the team or you don't make the team. You either catch the walleye or he breaks off and you don't catch the walleye. You either make the goal or you miss the goal. All right? You either get elected president or not. All right. So there's two outcomes when you do binomial. And there's also got to be a fixed number of trials. Like you don't just say, well, he might shoot some free throws at the end of the game. What's his chance of getting some points? It's too vague, of course. That'd be too vague for anything. But you need this fixed number of trials. Like you're going to say, you get 8 shots. Okay. Now, what makes these different is that on a tree diagram, you can change each probability and have it depend on the one before. Like, for instance, you can have the first roll of the die have a 70% chance of getting a certain number. And then you change dice to like the weighted dice, and now you have like a 90% chance that you're going to get that number. You can change your percentages. In this, you can't. And I just want to give you an example of the problem that you used to do. You might say, well, if you were to flip a coin 20 times, how many would you expect to get for heads? 10. But would you agree that there's a decent chance that if you flip a coin 20 times, that you're going to get, like, not 10, but maybe 9? This can tell you exactly what your probability is that that'll happen. Instead of just saying, well, I know the coin should be about 50-50 and I should get about 10 out of 20, you can find out exactly what's the probability that's happening. I'll give you another example. Let's say that a kid gets 4 free throws at the end of a game. Would you agree there are 5 things that could happen? He could make none, or 1, or 2, or 3, or 4. Get what I'm saying? If a kid has a decent free throw shooting percentage, do you agree it's pretty unlikely he's not going to make any? He's going to miss all 5 free throws. It's a very small chance. All the chances added up would add up to 100%. All right, so let's do that problem. So we got this kid, and he's going to shoot free throws, and he's going to shoot 4 of them. You could make a gigantomundo tree. Don't make this, but he could make or miss. The second shot, make or miss. Third shot, make or miss. Fourth shot, make or miss. Do you get how this would be a massive tree to have to draw out for this situation? I haven't even got close to done with it yet. Okay, but I'm going to show you this thing called binomial that comes in and saves the day, and you don't have to make the gigantomundo tree. You can say, write this down, please. Get on a blank sheet. Add a blank sheet. C, and then 2 parentheses. And if there's going to be 4 shots that this kid's going to take at the end of the game, then it's 4 to choose from. And we're going to figure out the probability that this kid is going to make. Let's say that they're a 75% free throw shooter. Let's see what the probability is that they will actually shoot and get 3 out of 4 shots. It seems like it should be a 75% chance that they're going to get 3 out of 4 shots, but it's not. Wouldn't you agree it's fairly likely that they'll get 4 out of 4 shots? And also fairly likely they'll get 3 out of 4 shots. And also fairly likely that they'll get 2 out of 4 shots. Okay? It's not very likely they'll only get 1, etc. So we're going to figure out the probability of making 3 out of 4 shots. Write this down. 4, choose 3, and this is the makes, and this is the misses. You know, I'm going to change make to hit, only because on my little diagram later it's called hit and miss. You hit the shot. Okay. And then the hit percent chance is 75% chance. That means the miss percent chance is what? 0.25. And then we're almost done setting up our binomial. This is a theorem. It's a formula that you can use. Now we need to know how many of these hits do I have? I have 3 hits. How many misses do I have? I have 1. All right, you should have this one good example written down. Why are you looking around the room? Do you need something? Okay, then get to work. All right. So this is a thing I can do with my calculator with the NCR button. You should know where that is under math. Grab your calculator, type in for NCR, and that's under math, probability. If you arrow over to probability, then there's an NCR option. And for those of you that were too slow, what was this first answer here? 4. That's if we had drawn out a giant tree diagram. That's all of the different paths, the different routes I could have taken to end up making 3 out of 4 shots. Like I could make the first 3 and miss the last one. I could make the first one and then miss 1 and then make the last 2. There's a lot of different routes. There's 4 to be specific. Next. Actually, I can leave that there. Next, I need this. 0.75 to the third. Somebody with a calculator with fast fingers, what'd you get? 0.421. Good enough. And then the miss, 0.25 to the 1. I bet you I can do that in my head, right? 0.25. Yeah, multiply that all out. Try it. 4 times 0.421 times 0.25. Why did I multiply? That was just to the 1 power, which just means... Why do I... Okay, I don't get your question. Do you not understand why the last part of the formula is there? Okay. You know if we were going to go across the tree, the big tree I was drawing out, do you know how there'd be like little fractions on each one? 75% chance of making, 75% chance of making, 25% chance of making? Well, what does this mean? That means I had 3 0.75s in my route. So if I make 3 in this one, here's an example one. I could have gone down this route on my tree. I make it, I make it, I make it, and then I miss. So see how there's 3 75s and 1 0.25? And that could have been in another way. I could have like started off by making the first 2, and then maybe I missed this one. So another route I'll do in green here could have been like this. Make, then I miss, and then I make again. See, that's got 3 75s and 1 25. So that's where this formula comes from. But if you don't even understand that, as long as you know how to set it up, you're going to survive this test. And this is the last thing I got to teach you before you take the big test. Test happens on Wednesday. So we'll have learning this today, making sure you totally understand things on Monday and Tuesday, and then the test Wednesday. Okay? All right, so back to, where was this when you actually multiplied it all out? 0.421. What does that mean? That means there was only a 42% chance that the kid was actually going to hit 3 out of 4 shots. Even though he is a 75% free throw shooter, and it seems like he should make 75%, well, there's only a 42% chance he would. Because there's also a decent chance that he'd make 4 out of 4. Right? Let's figure that out. Would you please, right now, do the same formula I just did, except now you're smart enough to change that to be 4 out of 4. So it's a C in the front, 2 sets of parentheses. Got 4 shots, and now he's going to make what? 4. Still a 75 and a 25. But now these numbers need to change. Multiply it all out. So let's say the kid's name is Josh, and Josh he has a decent chance he's going to make 3 out of 4. There's a 42% chance he's going to do that. But there's also who's got the answer for this one? That's the question, isn't it? Okay. I don't know. Who thinks they have the answer for this one? What do you think it is? Yep. Probably the same thing then. So we get 0.316? Okay, good. So this one's 0.316. The point is, got it all messy in there. There. Point is that there's a 30% chance he'll hit 4 out of 4. There's a 40% chance he'll hit 3 out of 4. Doesn't it make more sense that he'll hit 3 out of 4? He's a 75% free throw shooter. It's pretty likely he's going to do that. But there's also a decent chance he'll get 4 out of 4. And then what's the other one that there's a decent chance of? Getting 2 out of 4. And let's not do it right now, but if you wanted to, you'd figure that out, and let's say there's like a 20% chance of that, and then there's maybe only a 10% chance he'll miss all of them. All those percentages put together add up to 100%. All right, so the cool part is now that you've learned that, and I think judging by your body language and stuff that you're getting this, I can give you a whole new problem that sounds really hard, and it would literally take you an hour to figure out with a tree diagram. And you'll be able to figure it out in like 5 seconds. All right? And it's real world. Because all you guys, many of you guys, have been in sports before, and you know like your certain percentages. Like maybe you're a 80% free throw shooter. Or that's the one we just did. Let's change it to like soccer. Free kick. Okay? You've got a chance, your team has a chance to shoot 5 free kicks at the end of a game. And your team, on average, is, let's say, well, you guys that play soccer, what do you think would be an expectation? What do you think? It's like 75% chance of making a free kick, or I should be saying penalty kick. You're right. What do you think? Yeah. Realistically? But I was going to say, like, if you saw 10 penalty kicks, how many would you expect? Just not based on how good the goalie is or how good the kicker is. In a game, you saw 10 of them over the course of a season?
6.5.
All right. Let's go with 6. All right. So that's a 60% chance, right? All right. So here's the problem then. Write me one of these things with a C in front and 2 sets of parentheses, and fill it in for this. I want you to say it's a 60% chance of making, and therefore a 40% chance of missing. And I want to know if you have 5 chances to do that in a game, you got 5 shots. I need to know now which one I want to know about. Let's do the probability of making all 5 of them. If you're normally, your team is expected to make about 60% of those penalty kicks, what's the probability you'll make all 5? 5 out of 5. Yes, sir. Got an answer or question? Okay. All right. If this is the hit, as in you score, and this is the not, then the exponent is whatever number you were looking at, like to focus on. I want to focus on making 4 of them. You want 4 of those then, and in this case we'd have 0. Now, this is for the last problem. Now for the new problem I just did, you got this C here, and you got this percent and this percent. Do you get that this is 0.6 and this is 0.4? Raise your hand if you get that. Okay, good. Then do you get that this was 5 shots and we want to make 5? Raise your hand if you got that. Okay, so then the hard part is what do you put here and here, and you got to know which one's which. This is making it, and this is missing it. And I want 5 makes and no misses. And you might think that that's going to end up multiplying by 0, but it's not, because 0.4 to the 0 is really what? 1. And so therefore it really comes down to, in this one, to just this. And then this I can do too. If I have 5 things to choose from and I'm going to take all 5 of them out, how many ways can I do that? 1. Because the order didn't matter. Notice, I don't care what order I made the goals in. All right, so then the order doesn't matter. That's why it's a C. This is a 1, so that's easy. So it really just comes down to 0.6 times 5. And what is it? Point what? All right. Is it likely then? No, it's about a 7% chance your team would actually do that. Now, in your mind, do you think, is it likely, if you're normally shooting only 60% on these things, that you're going to make 5 in a row? No, that would be like freakishly amazing, awesome, and you'd be going crazy. Is it, okay, Is it more likely to make all of them than to miss some? No. If you're a 60%, if you normally only make them 60% of the time, don't you expect to miss a few? You would expect to miss a few. Nope. Because making all of them is really, wouldn't you, if you were watching the game, wouldn't that be unlikely and therefore people are excited about it? The probability of this is smaller. In fact, let's just find out. Let's do another one. It's just like this, except what do you guys think is pretty likely for this team to make? 3. So would you please figure out what's the probability they'll make 3? Same scenario, except this time they're making 3. All right, if you're making 3, it's a 3 here, then there's a 3 here, and then it'd be a 2 misses then. This is definitely harder because I can't do much of it in my head, because I don't know what 5 choose 3 is. It's a big number. That means there are 10 paths. If I had made a giant tree diagram, there are 10 paths that would have worked. Next thing, the 0.6 to the third. You get that one? Thank you. Next one, 0.4 to the second. I can do that in my head. 0.4 times 0.4 is 4 times 4 is 16 with a decimal over a couple spots. 0.16. Is that right? Hope so. And then multiply it all together. 0.345. So about a 34.5% chance. Call it about a 35% chance or so that they will make 3 shots. All right. What is the most unlikely thing of all? Missing all of them. Figure it out. This one, a lot of it can be done in your heads. Don't just blindly put it in the calculator. Think for a second and go, oh, there's only one way to do that, so I don't have to type all that junk in. It's making none, or missing all. So that's make 0. Make 0. Miss all of them. Do you get how this is what? 1. What's this? 1. 1 times 1 times that, which really means 0.4 to the 5th. Only 1% chance happen, but that'll happen. All right. That's binomial. It's really, really handy for solving complicated problems that would take a giant tree diagram, and it simplifies it down to super simple. It only works when there's like make or miss, simple problems that are, but that happens a lot in the real world, so this is a pretty handy formula. All right. I have a couple slides on here I want to actually talk about. Do you see how I have 3 of them painted with yellow? That was for hitting 2 and missing 1. Do you see how that worked? And then that's this part of the chart. I got 3 shots, and I want to make 2. This part would be 0.5 and 0.5 because it's 50-50. No, wait, I'm wrong. Sorry, 65 making it, and that would mean this is what, 35? And that's because, wait, I got to do this part too. 2 makes, 1 miss. And that's because there'd be 2 hits, and those are both 65s, and 1 miss, and that'd be 35. And that could happen in other ways. Like, I could have 2 hits and 1 miss on that route. But there's always 2 hits and 1 miss. So it's really just simplifying a tree diagram down so you don't have to draw the tree. All right. Don't figure it out, but write me the formula on your notes on this problem. Write the formula down. See if you do it right. Right away, the biggest number always has to go on the left, 50, and then I'm making 16. And I'm talking about heads and tails. I'm going to label with an H and a T. You don't have to, but it helps keep me organized. And then if it doesn't tell me on the probabilities, then they're probably the same. I really should say. And then it's 16 of those, and then the total is 50, so it must be 34. Raise your hand if you had that one right. Okay, good. And then as long as you can type at that point, you'd get it right. All right. Now I need to talk for a minute about add a blank page. Let's get warmed up for the little formative homework quiz. Instead of grading homework today, we are going to just be taking a little quiz on the formative side, 15% category. And it's about pizza questions and that kind of stuff. So let me explain them to you. Let's start with cards. I think it's a little easier to understand. So if you have a card problem, usually you're dealing with a full deck of cards. 52 cards. 52, and we always use C's for our card questions because the order doesn't matter. You pick up all your cards at once. And then it depends on the game, but a lot of times we use a 5-card game. All right, start by writing that out. On the top, I want you to write this out. What would you put if I wanted you to get 3 clubs? Well, there's got to be 2 parts because I can't get all my cards by just having clubs. So there's going to be 3 clubs out of how many clubs are there in the first place? 13, choose 3, and my other cards have to come from this next part, which is all the other things that are not clubs, 39, and I'm going to choose how many of those. There you go. Now, let's say you had goofed it up. One of your numbers was wrong. Isn't that, like, don't you think that's pretty likely if somebody messes it up that it'll be one of the numbers, not the C's that are going to be messed up. One number will be wrong. Watch what I can do to double check this. Do you see how those add up to 52? Yep. And this, and this, and this, the 3 plus the 2 adds up to the 5. All right? So we used that last hour to check in one of the complicated problems that I was doing, and it wasn't adding up, so we knew we weren't doing it right. All right, let's make another one like that. Let's say it's a 2-card game. This is called Texas Hold'em. What's the probability you will get 1 ace and 1 king? For those of you that play this game, you can appreciate that's a good hand. It happens every now and then. Happens not incredibly rarely, but it's, 2 cards being dealt. So that tells you the bottom. Top is, I want to know what's the probability of getting a 1 king and 1 ace. So it's always what I want over what's possible. The things that are possible are, yes, you can put 3 C's on top if you want to, but then the last one is kind of optional. Anyway, there are 52 cards in the deck, and I'm only going to get 2. 52, choose 2. Next, on the top, I got aces, and I got kings. There's 4 aces, not 13. There's 4, and I want one of them. And there's 4 kings, and I want one of them. Now, there's not only one way to do this, because you could get an ace of spades and a king of diamonds, or you could get an ace of clubs and a king of hearts. There's a lot of ways to do it. Specifically, there's 4 times 4 is 16 ways to do it. But there are a lot of possible hands you could get. What does 52 choose 2? Is it 52 choose? Are you sure that that's for 2 cards? I think some of you guys were choosing 5 cards. We had a 2-card game here. 1, 3, 2, 6? All right. So 16 out of 1,326. So when you're playing this game, there's only 1,300 possible hands you're going to get, which may not seem like a lot, but honestly, somebody who plays a lot of cards, you could see every single hand in a couple nights of playing. You would see every possible combo you could ever get. And whereas if you deal out 5 cards, you'd have to play for like a couple of months straight before you'd ever see every single hand. And we're talking like constantly, never stopping to eat. So much more likely to see every hand in this. All right, did you get how we set that up? Now, how is pizza problems like this. Because in a pizza problem, there might be a total of 50 toppings you can put on a pizza. But you can divide them into parts like diamonds and hearts and clubs. Just like you can divide a deck of cards up, the toppings can be divided up into like what? Meats, vegetables, cheeses, okay? So let's say that there's a total of 50 toppings. And let's say that there's 30 veggies, 15 meats, and 5 kinds of cheese. And pineapple. You're looking at the quiz, aren't you? Okay, the quiz has that question. It's the first question. Okay. Pineapple would be a fruit, so I would have, but mine already adds up to 50, so I'm going to stop there. But yeah, if I had added up to 49, it'd be because there's one more thing, and that's a fruit. Okay, and it's probably the only fruit you put on pizza, isn't it? Okay, anyway. Unless you count tomatoes, good point. All right, now, do you get that if I have 50 toppings and I'm going to have a 2-topping pizza, normally people choose cheese, but did you know there are people that don't have cheese in their pizza? That's true. Yeah, it could be they're lactose intolerant. Some people just really like it a different way. How about this? How many of you ever tried pizza without the sauce? I really like it. Do you like it? It is. You guys should try it sometimes. It's kind of like cheesy bread, but it's different. It's really good. And a lot of times you do a sauceless pizza where actually they have a white sauce, where it's like oil and maybe a little bit of garlic or something in the oil, and yeah, it's really good. Anyway, you should try it sometime. Back to, if there's 50 toppings, and I'm going to choose 2 toppings, that's how I start. I put the bottom on there, because there's a lot of possibilities. And let's say that we decide that we want to find the probability where we're going to do a meat, 15 meats, and a cheese. That's a pretty typical pizza. 5 cheeses. And let's say you get to pick 1 meat and 1 cheese. What did I just figure out? I figured out the probability that it would be your favorite pizza, which might be, I don't know, normal cheese and pepperoni or whatever it is. All right. Now, I actually did something a little different here. I didn't do your favorite pizza because how many of them would be your favorite pizza? Only 1. This isn't going to be 1, is it? That's going to be a whole bunch. What that's saying is, what's the probability that I get 1 of these? This is what I want, right? 1 of these kinds of pizza, which would be, there's 15 different kinds of meats and 5 different kinds of cheese. How many different pizzas could we make like that? So what I just figured out is, what's the probability that if we picked a completely random pizza, that we would end up getting one that had a meat and a cheese? All right, so then it's 7, is it 75 on top? Out of what was on the bottom? All right. Let's give you another pizza question. Now that you got the general idea, it's just like the cards. Couple C's on the top and one big total C thing on the bottom. All right, so this is not a probability this time. I just want you to tell me, if there's 50 toppings, how many different 3-topping pizzas could you make? Don't even have to figure it out with a calculator. Just write the formula. So what is it? 50, what? C, what? 3, that's it. That's how many different 3-topping pizzas there are. Now, what if you have a favorite that has 3 toppings? Sausage, cheese, mushroom be one of my favorites. That was my mom's favorite. So, roast beef. Anyway, if you have one favorite, then you have a 1 out of that chance you'll get it. All right. Let's say that you get to pick one cheese. And I'll go back to that screen so you can see how many there were. You get to pick one cheese, one meat, and one veggie. Now, what's the probability that you will get your favorite? If they're going to put on one meat, one cheese, and one veggie, so how many different ones could they make? Now this is different because before we just had all 50 toppings and they weren't going to necessarily even pick a cheese. They were just going to pick one of the toppings. This time I got to break it up and say there's 30 kinds of veggies and you're going to pick one. There's 15 kinds of meat and you're going to pick one. And there was 5 kinds of cheese and you're going to pick one. You're exactly right. And what is 1C1? 1. No. That's not on top. If we want to know how many there are, that's this. Now I'm changing it to a probability. And the probability of you getting your favorite one would be 1 out of all of that. Yes, in the back, raised your hand. Why are all of these in the bottom? Because now instead of just saying I can pick any 3 of the 50 toppings, I said you had to pick one meat, this was the meat, one cheese, and one veggie. That's why it's not just 50 choose 3 on the bottom. Do you get the difference between that? If I had done 50 choose 3, that would mean I could pick any of the 50 toppings, just pick 3 of them. And it could have been 3 meats. Okay, this would be different. The blue kind is different. That's where you could pick anything you want. This one, it said you had to pick one of each. And now, if you have a favorite, which is normal cheese and sausage and mushroom, then there's only one of those, so it's 1 out of all of this. All right. Just to make you feel better, last hour, the vast majority of kids get 7 out of 7 on this one, so this isn't going to be too bad. All right, so go to Skyward, go to the Skyward Assessments. There's only one out there, so make it easy to find. Find it. And last hour, there were a lot of kids that either would 4-finger swipe over to their notes to like write out the C's and stuff, or had a piece of paper out. So either way is fine with me. If you're techie enough, you can just have a blank sheet on your notes there and 4-finger swipe back and forth between the two, and it's pretty slick. I think you guys are allowed to forget the network Minnetonka guest. And that'd be the smartest thing. I'll show you that in a minute. I gotta stop the video here.